All right, this is Pre-Calculus B, Unit 5, Lesson 2, Operations with Vectors. We're going to do a couple of things. We're going to add vectors, subtract vectors, multiply vectors by scalars, those three things. And we're going to do them in various combinations. I'll leave it up to the lesson to go into detail about it, but we'll just kind of generally treat the subject. Okay, so let's draw two vectors here. So let's draw a Cartesian coordinate system. Here's our x-axis and our y-axis, and we're going to draw two vectors. The first vector will be 3 to the right and 5 up. So we'll call this V. V is 3 to the right and 5 up. Actually, let's put it over here. V equals 3, 5. Okay, and let's go ahead and draw it here. We're drawing it at the home position. Remember, vectors really don't care where they start and stop. If we're drawing them in the home position, we're drawing them with the tail at the origin. Okay, 3, 5. 3 right and 5 up. Okay, and let's draw a vector u, so that it is 2, 4, 6, and 2. Yeah, let's do that. So u, vector u, is going to be 6 to the right and 2 up. Okay, we're going to add these vectors. Now there's two ways generally to think about the addition of the vectors. One is just thinking of taking a vector and moving it, because remember, it doesn't matter where it starts. And you can add a vector by stacking them head to tail. So here we go. Let me demonstrate that here. So I'm going to take u. Okay, and we're going to stack it, put the tail on the head of vector v. Okay, and there we go. So this is u now, and the combination of the two can be thought of as from the tail of v to the head of u. Right? So we draw the resultant vector, that's what it's called, the resultant vector, as right here. Okay, now graphically we can see what the resultant vector is. So u plus v happens to be 2, 4, 6, 8, 9, 2, 4, 6, 7. So 9, 7. Okay, so the resultant vector can be found by stacking the tail of one of the vectors onto the head of the other. And it really doesn't matter which one. If I wanted to, I could take the green vector, v, and stack it on the head of the u vector. Okay, we need to combine layers here. Oh, wrong direction. There we go. All right, now let's try it here. Oh, gotta grab the right tool. Technology. Love it or hate it. It allows us to do a lot of things that we couldn't do otherwise. But when it misbehaves, or when we misunderstand or misuse it, we can stack the green tail to the purple purple head. And this brings out another idea here, and that is that we can use what's called the parallelogram method. Okay, so draw a parallelogram with both vectors, and it's the resultant vector is the diagonal of the parallelogram. All right, what I want to address next is the arithmetic, and that is that u plus v really amounts to adding adding components. 3, 5, actually 6, 2 if I'm going to be consistent. 6, 2 plus 3, 5 is really 6 plus 3, comma 2 plus 5, or 9, 7. So it's really quite simple. It really just comes down to vector addition being the in rectangular form, being the addition of the rectangular coordinates. And that's great. The mathematics is a little more involved. You use this trigonometry if we're given the vector in polar form, so in magnitude and direction form. But this lesson doesn't deal with that. Okay. Now we can apply this to all kinds of things. So we can do scalar multiplication, in which, and I'll just give you the rule, scalar multiplication, if I have k times vector q, and vector q happens to be vector AB, then the scalar is just k times A, k times B. It just makes it that k times bigger. In geometry we call this a dilation, right? And so let's do a fairly complex one that's more involved. It's not going to be really very complex, but all right, one that is definitely more involved. Okay, let's say we have this. We have u equaling 1, 5, and v equaling -2, 4. Okay, and let's do this. Let's do 5 times u minus 2 times v. Okay, it really comes down to this: 5 times vector u, 1, 5, minus 2 times vector v, -2, 4. 5 multiplied by the components, 5, comma 25. Minus 2, so think of the minus 2, think of the 2 as negative. -2 times -2, just like distributing in parentheses, is 4, -8. And then add the components. 5 plus 4 is 9. 25 minus 8 is 17. And so this is 5u minus 2v. All right. So it's really not terribly hard. It's just a little bit of a different way of thinking about things.